Now let's talk about input-output in CP programs. Some of the problems that we use will require either reading a lot of data or writing a lot of data or both. So in these cases, your code must do the reading and writing efficiently so that your programs do not time out because of input-output. The key to efficiency is to use buffering. So essentially, when you actually write data out, either to a file or to a terminal, so the actual writing will require what's known as a system call. And then there are lots of things going on in order for that writing to occur. So when you use a buffer, then when you write the data, you do not actually make the writing occur. The data is simply put in a buffer in your program. Only later, either when the buffer is full, or when your code force a flushing on the buffer. So which will happen, for example, when you close the file, then the buffer will be flushed so that everything that's still in the buffer will be written out. When you use buffer for writing, then a system call will be invoked only when the buffer is full. When you force the buffer, so then the number of system call is slow. It is small. So then it takes less time. Similarly for reading, if you have a buffer, then each time you can read in a big chunk of the data, and then you can parse them. Only when you run out of the input data to parse, then you need to do a system call to read in data again. If you don't do the buffering, then there will be lots of system call, then the program will be slow. So this concept of system call and exactly what's happening, this will be covered in courses, for example, 252. So if you're using Java, in order to make input efficient, there are several choices. By default, the default choice is to use a scanner, which is easy to use, but kind of slow. If you want to do things that's a little bit faster, you essentially use a buffer for reading. So you use something called a buffered reader to read in. So then each time it will read a bigger chunk of data. So with buffered reader, you can use a few ways to parse it. One of them is each time you read a line and then you feed that string into a string tokenizer, then this will divide up this string into multiple tokens. Or you can call split, which will split the string based on using white space characters. And finally, if you really need a fast reader, you can also use a custom code. We're going to show an example of that. So my personal choice is either I use scanner when input speed is not a problem. When the problem doesn't require a lot of reading input, I use scanner. If it does, then I will use this custom fast reader because it is the fastest approach. The only downside is I have to copy a big chunk of code that's into the source file, but that's not really a problem because I don't need to type those code. I just need to copy it. So for output, in order to make it efficient, what I do is I use the print writer, which add the buffering. So this way will make it more, output will be more efficient. And also print writer supports directly sending an object or a primitive data into this print writer. It will do the correct thing, converting that string and then adding things together, just like using system out. So when you use buffering, you remember that in Java you have to do a close at the end. So you have to explicitly call close on the print writer. Otherwise, when the program terminates, some of the data remain in the buffer may not be written out. So it doesn't actually do a final writing before the program terminates. So you need to do that. So if you want to know more on Java fast input output, you can read these notes at Geeks for Geeks. And you can also see the template code on Brightspace. So here I'm just going to briefly show that code. So this is the template code for Java that I uploaded to Brightspace. So it has a comparator for comparing two integer arrays based on first compare the first element. If they're the same, then compare the next. I find this is very useful. It's used for many problems, so I keep it in my template. And then the reader code is in here. It's actually quite long. So what it does, it's each time it will read in 2 to the 16 bytes, up to 2 to the 16 bytes in the buffer, and then when you need the data, it will just try to consume the data. So I have some in the comment here. I give some sort of a caveat about how to use this. You can read that, and if you encounter a problem, we can discuss that later. So for Java, I tried different methods for reading and write for input reading. In fact, there's another method I also tried that it's called the stream tokenizer. But stream tokenizer, sometimes it has behavior that are not quite expected in terms of parsing input in the context of CP, so I didn't put them here. So the way I tried it is I have files where each line had 100 integers, and so the smaller file will have 100,000 numbers, and this is the time it takes to read in those data using different methods. So as you can see, when the file gets bigger, the scanner is about 5 times, take 5 times more time than string tokenizer and string split, and this will be 30 times, I guess between 25 and 30 times. Around 25 times, no, between 25 and 30 times more time than fast reader. So, so that's if time is really an issue, you should use fast reader because it is significantly faster than all the other methods. But this is in the context where every line has 100 numbers, so then this will take a bit more time. If each line have fewer numbers, then the difference between fast reader and the other method will be less. If each line could have more numbers, then it will be a little bit more. So what if you are using C++? So in C++, it's actually simpler. So if you want the input to be fast, you add these 2 lines in the input. So you add this line and this line in the beginning of your program. So this function call, what it does, it disables synchronization between C and C++ input streams. So C++ input using cin and C input using scanf. So you can actually mix these 2 kinds of input in order to make sure that mixing you're still doing things, you're still reading things meaningfully. Because of effect of buffering, so this will add synchronization into that. But generally, I don't recommend using a C-style input syntax. So just use a C++, and definitely there's no need to mix them. So then, if you don't mix them, then you can set this. This will remove the synchronization cost. And this last one is they will. If you don't do this, then every time you want to read something, it will first flush the buffer to write data out. So this is useful when you have an interactive program, because think about a program that print a question and waiting for user to answer, or an interactive game, those kind of program. Then definitely you need this flushing behavior, but for our context, we don't. So our programs in general are not interactive. So then we can use this line to disable that, and this will also reduce the cost. So in terms of faster output, the only thing that matters is if you need to print a lot of output, a lot of lines, use a \n for new line instead of endl. Because endl will flush the buffer, so it defeats the purpose of buffering. So it will result in more system calls and slower performance. So because of the same reason, if you're printing debug information, you should use NDL instead of new line. And this is because if you are using debug information to figure out which point your program reaches based on the printed message, you want the message to be printed out instead of staying in the buffer. So just a final caveat, for interactive programs, you will want to synchronize input and output, and you will need to flush a buffer when needed. So in that case, you should use NDL instead of \n. But we do not use interactive program in the CP courses.